Welcome to The Deep Dive, the show where we cut through the noise and get straight to the insights you need to be truly well-informed. Today, we're plunging into a topic that's no longer just confined to code and algorithms. It's actively reshaping the very fabric of our daily lives. We are talking, of course, about artificial intelligence. It's evolving at a breathtaking pace, and with that evolution comes profound questions that stretch far beyond just the technical specifications of a particular model or system.
Exactly. The truth is, AI's impact is now so pervasive that understanding its broader implications, how it touches human lives, organizational resilience, and even, the societal fabric, is as critical as knowing how to build the algorithms themselves. We often think of AI in terms of its intelligence, but what about its responsibility?
That's it. And that's our mission for you today. We're taking a deep dive into a really critical part of that broader picture, drawing from Chapter 3, Part D of our core source material, the AAISM Review Manual First AEC.pdf. This section consciously shifts our focus from purely technical AI security aspects to its more profound societal and operational implications. We're going to unpack 4 absolutely essential pillars for anyone interacting with or deploying AI systems: privacy, ethical considerations, building trust, and ensuring safety.
Our goal is to extract the most important nuggets of knowledge from these pages, giving you a shortcut to truly being well-informed on these nuanced areas. You'll gain a holistic understanding of AI's non-technical but equally vital facets. Think of us as your expert guides, helping you see the connections you might miss when just reading the material.
This deep dive is all about experiencing those aha moments, connecting the dots between how an AI algorithm functions behind the scenes and its very real, tangible impact on individuals, on organizations, and on the broader global ecosystem. It's about recognizing that truly responsible AI demands a comprehensive, holistic view. So let's unpack this. Before we even talk about specific controls or solutions, it's crucial to first grasp the potential negative consequences that AI systems can introduce.
That's a foundational step, definitely. Because if we don't understand the potential harms, we can't design effective safeguards. Our source material does an excellent job of highlighting 3 key categories of harm that AI can introduce, moving beyond just simple data breaches to truly systemic risks. This comprehensive view helps to frame why all the controls and strategies we'll discuss later are so absolutely necessary. It broadens our perspective on what security really means in the AI context.
Okay, so let's start with the most immediate and direct impact: harm to an individual or a group. This category focuses on those direct negative impacts on people, whether you're a singular user interacting with an AI or part of a collective group that's affected by its decisions. It's about how AI directly influences the human experience, sometimes in ways we might not initially foresee.
This is where the abstract notion of AI becomes deeply personal. Yeah. The manual provides very specific examples that really bring this to life. For instance, personal data breaches are a classic concern, where sensitive personal information processed by AI gets unauthorized access or disclosure. But here's the twist with AI. It often processes vast quantities of deeply granular data, sometimes inferring sensitive details, even from seemingly innocuous inputs. A breach of an AI system could expose far more about an individual's life, habits, or even future predictions than a traditional database breach. It's a different scale.
A different scale, exactly. And then there's discrimination. This isn't just a theoretical issue. It's unfair or biased treatment by AI systems, often unfortunately due to biased training data. Imagine an AI used in hiring that inadvertently screens out qualified candidates based on their gender, ethnicity, or even zip code, not because of their skills, but because the historical data it learned from had subtle or overt biases. The aha here is that AI doesn't just replicate our past biases, it automates and scales them, making them harder to detect, challenge, and dismantle. It turns historical prejudice into a future-proof algorithm, often without anyone intending it.
Precisely. And that leads us to lack of transparency or misrepresentation. This is where AI decisions are opaque, unexplained, or provide misleading information, leading to a profound lack of understanding or trust. If an AI system, say, in a loan application process tells you no without providing clear, understandable reasons, that's a direct and frustrating impact. It leaves individuals feeling helpless and unfairly judged, unable to learn or appeal.
Exactly, and that ties into loss of control over personal data. Individuals can feel completely powerless to manage or control how their own information is used by AI, especially when that AI is continuously learning, adapting, and making inferences about them based on data they may not even realize is being collected or correlated. It's like a digital shadow that grows increasingly complex without your conscious direction.
Yeah, it's unsettling. And beyond the digital realm, there's physical harm. This is when AI systems cause actual bodily injury or unsafe conditions. The most obvious examples are autonomous vehicles malfunctioning or industrial robots in a factory operating outside their safe parameters. But think even about AI in medical devices. An error there could lead to severe health consequences. The stakes immediately escalate when AI interacts with the physical world.
Hmm. And it's not just physical harm. The source also points to mental harm, psychological distress, or negative emotional impacts from AI interactions. This could be anything from an AI chatbot designed to be helpful inadvertently causing distress due to inappropriate responses, or even the subtle but persistent effects of AI-driven social media algorithms on mental well-being, like fostering addiction or generating unrealistic comparisons.
Right, those subtle effects can really add up. And then the broadest individual impact, socio-emotional harm. These are the broader negative effects on well-being or social connections caused by AI. Consider how AI-driven automation might erode certain types of human interaction, or how pervasive surveillance technology, even if well-intentioned, could foster a climate of distrust and impact community cohesion. These are often diffuse, harder to quantify, but can have profound long-term effects on individual happiness and societal norms.
So, given all these distinct ways AI can introduce harm, what stands out to you about how AI, even when designed for good intentions, can introduce new or significantly amplified risks for these types of harm compared to traditional systems? Why is it so crucial to consider not just direct measurable harm, but also these more subtle socio-emotional impacts?
That's a critical distinction, yeah. Traditional systems, while it can certainly cause harm, often operate within more defined parameters. AI, especially with its capacity for machine learning and deep learning, brings an entirely new dimension. Its ability to process and infer from massive, complex, and often unstructured data sets means it can generate insights and make decisions at a scale and speed that humans simply cannot. This amplification of decision-making power also dramatically amplifies the potential for unintended consequences.
So it's not just the type of harm, but the magnitude and speed at which it can occur. That's the key difference.
Exactly. A traditional system might have data breaches, but an AI model can perpetuate discrimination on a massive systemic scale, affecting entire demographics instantly. Or its opaque nature can systematically erode trust in interactions across countless users, leading to widespread disillusionment. The socio-emotional harms are particularly challenging because they're often diffuse, harder to trace directly back to a single AI decision. But they can have profound, insidious long-term effects on individual well-being and broader societal norms. Ignoring them is ignoring a fundamental part of the human experience that AI is increasingly touching. It forces us to think about the broader human flourishing, not just technical efficiency.
That's a powerful point. It's a sobering reminder that AI is not just a tool. It's a transformative force that demands a new level of foresight. Now let's pivot to the organizational level. What happens when AI goes sideways for the companies and entities deploying it? Our source material also highlights harm to an organization. This encompasses the negative consequences AI can impose on the very entities deploying or using it, directly impacting their operations and their standing in the market.
Precisely. The manual lists several key examples here that illustrate how deeply intertwined AI risk is with core business functions. First, business operations disruption. AI failures or errors can lead to complete operational halts or significant inefficiencies. Imagine an AI-driven logistics system failing, bringing an entire global supply chain to a standstill. Or an AI-powered customer service bot suddenly providing incorrect information, overwhelming human support staff. The reliance on AI means its failure points become single points of failure for the entire operation.
And that, of course, very quickly leads to financial loss. This is the direct monetary impact from AI errors, system failures, or even legal penalties resulting from AI incidents. This isn't just about losing a few dollars. It can involve massive revenue loss from disrupted operations, costly system repairs, or multi-million-dollar regulatory fines, especially with evolving AI legislation.
Definitely. Then there's reputational damage. This is public backlash, a profound loss of customer trust, or brand erosion due to AI incidents or ethical missteps. A highly publicized AI bias incident, for example, where an AI system is shown to be unfair in mortgage lending or healthcare, can be devastating to a company's image and very difficult to recover from, as trust is hard-won and easily lost.
Which naturally brings us to legal regulatory noncompliance. Penalties or lawsuits for not adhering to burgeoning AI laws, industry standards, or ever-evolving regulations can be incredibly severe. We're seeing new regulations emerge globally, like the EU AI Act, which will impose strict requirements. Ignoring privacy regulations, for instance, or failing to disclose how an AI makes decisions can lead to massive fines and protracted legal battles.
Hmm. And we can't forget security breaches. While traditional systems are vulnerable, AI systems can become a completely new vector for cyber attacks or introduce internal security vulnerabilities that are unique to AI. The advanced capabilities of AI can, paradoxically, be exploited for sophisticated attacks against the very organizations that deploy them. Think about adversarial attacks that trick an AI into misclassifying something critical, or data purging attacks that subtly alter an AI's learned behavior.
Yes, and closely related is the loss of intellectual property. AI systems could compromise proprietary data, algorithms, or sensitive business information if not properly secured. The training data itself or the unique architecture of an AI model could be a multi-million-dollar asset. If that gets compromised, it's a huge competitive risk in today's knowledge-driven landscape.
What's truly fascinating here is how AI intertwines with an organization's very core, affecting not just its IT department, but its strategic direction, its public face, and its bottom line. How does AI fundamentally change the nature of operational risk and the scope of what needs to be protected, from traditional financial assets to brand image and complex compliance obligations? It really broadens the scope, doesn't it?
It changes everything because AI isn't just processing data, it's creating new insights, making decisions, and often automating processes at a scale and speed that humans can't possibly match. This means a single AI error, a biased outcome, or a security vulnerability can have a cascading effect across an entire organization, impacting financial stability, reputation, and legal standing simultaneously. The scope of protection isn't just about securing databases, it expands to cover the integrity, fairness, and predictability of the AI's decisions. Not just the security of the data it processes, it shifts from protecting information to protecting intelligence.
That holistic view is absolutely essential for risk management in the modern enterprise. Moving to the broader scope, we have harm to an ecosystem. This category captures the systemic risks AI poses, affecting interconnected systems, society at large, and even the environment. It truly underscores AI's far-reaching potential for widespread impact.
Let's look at some examples from the source. First, harm to interconnected or interdependent systems. This describes cascading failures across complex networks or critical infrastructure due to AI integration. Think about AI managing a city's power grid, its transportation network, or national defense systems. A failure or compromise in such an AI could have massive widespread impacts, paralyzing essential services for millions. It's no longer an isolated incident, it's a systemic risk.
It really is.
Yeah.
Then there's the fundamental erosion of trust in AI. This is a widespread public or institutional loss of faith in AI technologies, which could severely impact innovation and adoption across entire societies. If people don't trust AI systems in critical applications like healthcare or finance, they won't use them, halting progress and preventing beneficial applications from reaching their full potential. This isn't just about one company's reputation. It's about society's willingness to embrace a new technological frontier.
And that leads directly to reduced social well-being. AI could negatively affect societal structures, employment, equity, or community cohesion on a grand scale. For example, if AI-driven automation leads to mass unemployment without adequate reskilling or social safety nets, or if AI systems exacerbate existing inequalities, it could lead to widespread social unrest or profound shifts in quality of life.
Beyond that, there are global AI threats. These are large-scale systemic risks from AI, such as the proliferation of autonomous weapons systems that operate without human oversight, or widespread misinformation campaigns orchestrated and amplified by AI, which could destabilize entire nations or global relations. The scale of potential harm becomes geopolitical.
And finally, an often overlooked but crucial aspect, environmental harm. AI operations can consume excessive energy resources, especially for training the increasingly large and complex models we see today. The carbon footprint of a single large AI training run can be equivalent to many tons of CO2 emissions. If not managed responsibly, this contributes significantly to environmental degradation, which has long-term ecosystem consequences.
That's a really important point. This raises an important question, particularly given this broad scope. How does AI push us to think beyond immediate organizational boundaries and truly consider its long-term, far-reaching effects on the global landscape? And why, in this context, is the concept of trust in AI so fundamental to its widespread adoption and responsible development?
It forces us to think systemically, almost existentially. Unlike most technologies, AI has the unique potential to learn, adapt, and operate with increasing autonomy, integrating itself deeply into critical infrastructure and societal functions. Its effects are rarely isolated, they ripple through economies, social structures, and even geopolitical stability. So, when we talk about trust in AI, it's not just about a user trusting a chatbot. It's about society having a fundamental faith that AI systems are being developed and deployed responsibly, transparently, and safely. Without that broad societal trust, adoption slows, or worse, people actively resist beneficial applications due to fear of the unknown or past failures. Trust acts as a social license to operate, a necessary condition for AI to fulfill its potential for good, rather than becoming a source of systemic risk.
That's beautifully put. And those potential harms across individuals, organizations, and ecosystems underscore the absolute necessity of robust controls. This brings us to our next critical area, privacy, and specifically AI privacy.
Okay, let's really unpack this. AI systems, by their very nature, thrive on data, and often a huge amount of personal data. Ensuring privacy is paramount here, not only for regulatory compliance, which is a significant factor, but also for maintaining user trust and avoiding those significant harms we just discussed. If data isn't handled privately, all those risks we covered become much more immediate.
The manual dedicates Section 3.6 to the foundation of AI privacy, and its core idea is vital. Privacy is intrinsically linked to how data is managed, processed, and secured throughout its entire life cycle within AI systems. This isn't an afterthought. It's about designing AI with privacy in mind, from the very inception of a project to its ongoing deployment and even decommissioning.
So this isn't just about putting a privacy policy on a website, is it? This sounds a lot like the concept of privacy by design. Our source really emphasizes the need for strong data governance, which means embedding privacy considerations from the very outset of an AI project, not just as an afterthought tacked on at the end. It's a proactive, engineering-first approach to protecting personal data. You build it in, rather than trying to bolt it on later.
Exactly. It's a fundamental shift from reactive compliance to proactive engineering and ethical integration. And here's where it gets really interesting and poses unique challenges for AI. For personal data, explicit consent is crucial. The manual clarifies that this isn't just a one-time checkbox. Users must have the right to withdraw consent and, importantly, have their data deleted. This poses unique and significant challenges for continuously learning AI models, which are constantly adapting and reshaping their understanding based on the data they ingest. How do you unteach an AI something it has learned?
That's a huge hurdle for AI, and it makes you think about how different AI is from traditional software. The source outlines several fundamental rights related to personal data that are greatly amplified in the AI context, really raising the bar for developers. For instance, the right to access. Individuals can obtain data collected about them, which is vital for fostering transparency. This means not just the raw data, but understanding what the AI has inferred or created about them.
Then there's the right to rectification. If data is inaccurate, individuals have the right to demand corrections. But think about it. What happens if an AI model has already learned from faulty or biased data? Correcting the source data doesn't automatically correct the model's learned behavior, which might now be embedded deep within its complex parameters. It's like trying to correct a mistake in a cake after it's already baked. You can't just pull out the bad ingredient.
A really good analogy that perfectly captures the complexity. And then the right to notification. Users should be clearly and continuously informed about how their data is being used and processed by AI. This goes beyond a simple static privacy policy. It's about clear, ongoing communication, especially as AI models evolve and potentially find new uses for data.
One of the most challenging rights, both legally and technically, is the right to be forgotten, or erasure. Upon request, personal data must be destroyed. This is a significant technical challenge for AI models trained on vast datasets. How do you truly unlearn specific data points without compromising the model's integrity or performance? Imagine a search engine trying to forget every instance of a person's name without breaking its entire index. It's a monumental task that research is still grappling with.
And it really makes you wonder if our current technical architectures are even capable of meeting these demands. Then we have the right to data portability, the ability for individuals to transfer their data between different services. This empowers users and theoretically fosters competition, giving them more control over their digital lives. But again, how do you port the value an AI has derived from that data, not just the raw data itself?
Good question. And the right to restrict processing. Giving individuals the ability to limit how an organization can use their data. This could mean allowing data for one purpose but not another, adding layers of complexity to AI development, and requiring incredibly granular data management systems. It's not just yes or no to data use, but a nuanced spectrum.
So, when you think about the practical implications of these rights for AI development, it becomes clear how uniquely challenging this is. How do you design an AI system that genuinely allows data to be unlearned or easily transferred in a meaningful way, especially considering these compliance inferred insights? This raises a truly important question. Are our current data management practices sufficient for the amplified demands and complexities of AI systems, particularly with these heightened privacy rights?
The short answer, as you alluded to earlier, is often no, not without significant re-architecture and innovative approaches. Our traditional data management practices are largely designed for static databases, for data that sits in discrete records. AI, however, works with dynamic, continuously learning models where information is often diffused throughout the model's parameters. The challenge with unlearning is that a neural network, for example, doesn't store data in discrete records. It's encoded in the model's learned weights. Removing one person's data might require retraining the entire model, which can be computationally expensive and time-consuming. Or using advanced techniques like differential privacy, which aim to add noise to data to protect individual privacy while still allowing for analysis. And for data portability, the AI's derived insights are often proprietary. It's not just your original data you're asking to transfer, but the AI's intelligence about that data, which is far more complex to move between systems. This pushes the boundaries of our current technical capabilities and legal frameworks.
That truly highlights the complexity and the cutting-edge nature of this problem. It's not just a compliance checkbox, it's a deep technical and ethical challenge. The source also explicitly mentions the need for disclosure requirements when using third-party AI models or if AI systems are part of a closed system. This highlights the intricate supply chain and interconnectedness of modern AI solutions. You need to understand how their models handle privacy, not just your own. You're only as strong as your weakest link.
Which brings us to the actual nuts and bolts, the controls. Section 3.6.1 of the manual outlines specific practical controls that organizations can implement to operationalize these AI privacy principles. These are the actionable steps, the engineering solutions, for protecting data in AI throughout its lifecycle.
So let's dive into some of these key controls.
Yeah.
First, data minimization. This means only collecting and processing data that is absolutely necessary for the AI's intended function. Less data means less risk, plain and simple. In AI, this is critical because the more data you feed it, the more potential for privacy leakage, even if unintended.
And coupled with that is purpose limitation, ensuring that data collected for a specific purpose is not repurposed for other uses without explicit renewed consent. This prevents data creep, where data collected for one benign purpose slowly gets used for something entirely different, eroding trust and privacy.
Transparency and explainability are fundamental here too, making it clear how AI uses data and why it makes certain decisions. This is foundational for building and maintaining user confidence and trust. If you can't understand what's happening with your data, you can't trust the system.
Naturally, security measures are critical. Implementing standard cybersecurity controls like encryption, robust access controls, and multi-factor authentication becomes even more crucial for AI data, especially sensitive training data. The impact of a breach is amplified when it involves AI-processed information, as it could reveal far more than raw data.
Then we have data retention policies, clearly defined policies for how long data is stored, aligning with legal and business requirements. The less time data is stored, the less risk it poses. Don't keep data longer than you absolutely need it.
And data quality, ensuring the accuracy, completeness, and timeliness of data used by AI. The old adage, garbage in, garbage out, applies incredibly strongly to AI outcomes and privacy. Biased or inaccurate data can lead to unfair or discriminatory AI decisions, which directly translate to privacy violations and harm.
And circling back to a foundational principle, privacy by design, integrating privacy controls and considerations into every stage of the AI development lifecycle, from conceptualization to deployment. It's not an add-on, it's inherent to the system's architecture.
To effectively evaluate that, organizations should conduct privacy impact assessments, PIAs. Regularly conducting these assessments helps to identify, evaluate, and mitigate privacy risks before deploying AI systems, rather than reacting after an incident occurs. This is a proactive risk management tool.
For managing user permissions, consent management is key. Establishing robust systems for obtaining, tracking, and honoring user consent, including clear and easy mechanisms for withdrawal. This needs to be a dynamic, ongoing process, not a static checkbox.
Related to that are user controls, providing users with clear and accessible mechanisms to manage their data preferences and privacy settings within the AI system. This gives them agency and a sense of ownership over their digital footprint.
And to support those rights, data subject rights support. Operationalizing processes to support individuals in exercising their privacy rights, such as responding to access or erasure requests in a timely and compliant manner. This requires dedicated teams and streamlined processes.
Given the interconnected nature of AI, third-party data handling is vital. Implementing specific protocols and contracts for securely managing data shared with or sourced from third-party vendors or partners. As you said earlier, your privacy posture is only as strong as your weakest link in the supply chain.
For accountability and continuous improvement, auditing and logging are indispensable. Maintaining comprehensive records of data access, AI model usage, and privacy-related events for accountability and compliance, allowing for forensic analysis if issues arise. This provides a crucial paper trail.
Then there's data anonymization and pseudonymization, employing techniques to protect sensitive data by masking identities while still allowing for data analysis. This is a continuous area of research and challenge in the AI space because, as we discussed, AI can often re-identify individuals even from seemingly anonymized data due to its inferential capabilities.
Right. And as a last line of defense, a robust breach response plan. Having a predefined and tested plan for how to react to AI-related data breaches, minimizing harm, and ensuring swift recovery, this isn't just about IT systems, it's about how to handle breaches when AI has been compromised or misused.
Finally, regular training, ensuring all staff involved in AI development, deployment, and management are educated on privacy best practices and regulatory requirements. Human error and a lack of awareness is often the significant vulnerability that can undermine even the most robust technical controls.
Okay, let's unpack this a bit more. While many of these controls might seem familiar from traditional IT security, how does AI amplify their importance or introduce new complexities? For instance, how do you truly anonymize data that an AI might later infer something sensitive from? Or how do you manage consent for a model that continuously learns and adapts? It seems like AI makes all these harder, not easier.
You're absolutely right. AI amplifies these controls because of its unique characteristics and capabilities. Take anonymization in AI. Traditional anonymization might mask explicit identifiers like names or social security numbers. But an AI, with its advanced pattern recognition capabilities, might be able to re-identify individuals by combining seemingly innocuous data points. This is what we call inferential privacy risks. For example, even if names are removed, an AI might combine location data, purchasing habits, and timestamps to pinpoint an individual or even infer their health status. This means the definition of personally identifiable information becomes much broader and more dynamic with AI.
So it's not enough to just remove names. You have to consider the potential for re-identification through subtle correlations. That's tricky.
Exactly. And regarding consent for continuously learning models, it's a legal and ethical minefield. Does consent given for a model at one point in time still apply as the model evolves and its capabilities change, potentially using the data in new, unforeseen ways? If an AI is constantly learning from new interactions and data streams, how often do you need to reobtain consent? This demands dynamic consent mechanisms and continuous notification strategies that are still being developed, pushing the boundaries of current legal and technological frameworks. These aren't just security controls, they're AI-specific governance challenges that require deep thought and proactive innovation.
That makes perfect sense. These aren't just security controls. They're fundamentally AI-specific governance challenges that touch on every aspect of the system. Moving on, beyond data privacy, trust is the bedrock for AI's acceptance and successful integration. If users, organizations, and society don't trust AI, its vast potential will simply remain unrealized. It's the essential ingredient for adoption.
Absolutely. The source material in Section 3.7 clearly states that trust in AI is deeply linked to the clarity of its decisions, its ability to prevent security incidents, and the overall security posture of the systems. An untrustworthy AI is inherently a security and adoption risk. It's not a nice-to-have, it's a fundamental requirement. If users don't believe the AI is fair, secure, or predictable, they simply won't engage with it, regardless of its technical brilliance.
And here's where it gets really interesting. Transparency and explainability. These are not just buzzwords, they are absolutely essential for fostering trust. If users or regulators or even the developers themselves can't understand why an AI made a particular decision, trust erodes incredibly quickly. The ability to articulate an AI's reasoning, to trace its decision-making process, is vital, especially in high-stakes situations. It moves AI from a mysterious oracle to a reliable partner.
This brings up the notorious black box challenge. The manual highlights that many advanced AI models, especially those built using sophisticated machine learning or deep learning techniques, often operate as black boxes. This means their internal workings are incredibly complex and opaque, making it difficult to explain how they arrived at a particular decision, identify underlying biases, or even assure safety and fairness. Imagine trying to explain why a super complex neural network made a certain medical diagnosis. It's incredibly difficult. This inherent lack of transparency directly impacts trust, particularly in business-critical applications where accountability is paramount.
And unlike traditional software, where you write the code and it generally behaves predictably, AI models are continuously learning and evolving. This means managing trust is an ongoing process, not a one-time check at deployment. It requires continuous monitoring, validation, and reassessment throughout the entire AI lifecycle. You have to keep an eye on it constantly, as its behavior can subtly shift over time as it ingests new data.
Right. What's fascinating here is the concept of an AI model being able to fail gracefully.
Hmm.
This means that when an AI system encounters unforeseen situations or errors,
Mm.
especially those impacting human lives, think about AI in medical diagnosis or autonomous systems, it should degrade predictably and safely, rather than causing catastrophic or unmanageable failures. For example, a self-driving car should pull over safely if its sensors fail, not swerve erratically. It's all about designing for resilience and, ultimately, human safety, which in turn builds public trust.
And we can't ignore the inherent flaws in the data itself. AI models are often trained on vast data sets that can contain inherent biases, inaccuracies, or even unexpected patterns. The source points out that these unknowns can lead to unintended consequences and unfair outcomes. For example, an AI designed for facial recognition might perform poorly on certain demographics if its training data was disproportionately skewed. This further erodes trust if not addressed proactively through robust data validation and bias detection.
hmm This raises an important question. How do organizations balance the immense power and efficiency of these black box AI systems with the fundamental need for transparency and trust? It's a key challenge for AI governance and demands innovative solutions that go beyond simple coding.
It's a genuine tightrope walk, isn't it? On one hand, you want the incredible predictive power and efficiency that these complex, sometimes opaque AI models offer. On the other hand, you absolutely cannot sacrifice accountability, fairness, and public confidence. It means investing heavily in interpretability tools, which try to shed light on why an AI made a decision, and rigorous, continuous testing for bias. It also means building in human oversight, as we'll discuss later. It's about accepting that some computational complexity is unavoidable, but striving for clarity and explainability wherever possible to maintain that crucial public confidence. It's the difference between blindly trusting a magic box and understanding how a powerful tool works.
Absolutely. And that leads us to our next critical pillar. Beyond data privacy and trust, AI systems, especially those interacting with the physical world, can pose direct safety risks to individuals and property. This section of our source material, 3.8, delves into these critical concerns.
The manual directly calls out physical safety as a major concern with AI, giving concrete examples like grocery store robots or autonomous vehicles. This instantly makes the abstract, tangible AI moving from the server room to the real world means entirely new safety considerations we might not have had before. It's not just about data integrity, it's about life and limb.
And here's a critical link. Robust security measures are not just about protecting data. They are absolutely crucial for preventing an AI system from being compromised or malfunctioning in a way that could cause physical harm. And insecure AI is, by definition, an unsafe AI. Think about a smart factory with AI-controlled machinery. If that AI is maliciously exploited or suffers a critical bug, it could cause significant injury or property damage. Cybersecurity in this context directly translates to physical safety.
Beyond the technical, the source acknowledges the deeper ethical and philosophical dilemmas that AI safety raises. If an AI makes independent decisions that lead to harm, who is ultimately responsible? Is it the developer, the deployer, the operator, or the end user? This isn't just a technical problem, it's a profound legal, ethical, and societal one that our legal systems are still grappling with.
Indeed. The manual outlines several key considerations for safety. First, self-regulation. The responsibility largely falls on AI developers and deployers to ensure ethical and safe AI, often going beyond minimum compliance to establish industry best practices and internal codes of conduct. It's a recognition that regulation often lags behind technological advancement, placing the onus on those building the tech.
Then there's accountability. This means clearly defining who is accountable when an AI system's actions lead to harm. This is a complex legal minefield, trying to trace responsibility through a complex AI system and its developers, deployers, and users.
Right. And managing expectations. Carefully managing what users and the public expect from AI decisions and capabilities is vital. Overpromising or misrepresenting AI's abilities can lead to dangerous misuse or over-reliance, where people trust the AI beyond its actual capabilities, leading to unsafe situations.
The overarching principle should always be beneficial use, emphasizing that AI development should prioritize applications that contribute positively to society's well-being, avoiding or minimizing harmful uses. This guides the entire development process toward responsible innovation.
Also, sensitive data handling requires extreme caution. When AI processes semantically sensitive information like health data, marketing profiles, or financial data, its potential for misuse or manipulation is significantly amplified. If this data falls into the wrong hands or is used inappropriately by the AI itself, it can pose direct safety risks, such as targeted scams, medical misdiagnosis, or financial fraud.
And speaking of manipulation, the manual highlights a critical safety concern: the ability of AI to manipulate data. This includes generative adversarial networks, or GANs, which can create incredibly realistic fake images, audio, or video. We're talking about deepfakes.
Yes, deepfakes are a prime and concerning example of this safety concern. GANs can produce highly convincing deepfakes that are extremely difficult, if not impossible, for the average person to distinguish from reality. Imagine a video of a world leader saying something they never said, or an audio recording of someone's voice being used to commit fraud. This raises significant safety concerns regarding misrepresentation, identity theft, fraud, and the potential for widespread malicious use, such as spreading misinformation to influence public opinion, impersonating individuals for nefarious purposes, or even creating fabricated evidence. It's a powerful technology with a profound dark side if not managed safely and responsibly. The implications for trust and the integrity of information are enormous.
That's chilling when you think about it. To counter these pervasive threats, the manual also provides controls for AI supervision and safety. These controls are vital for overseeing AI systems to ensure they operate safely and, as intended, acting as constant watchdogs over the AI.
One key category is logging and monitoring. These are the eyes and ears of AI operations, providing continuous visibility into system behavior. This involves things like data pipeline monitoring, ensuring data flows correctly and securely without corruption from its source to the AI model itself. It's about knowing if the AI is getting the right fuel.
Plus, proactive monitoring, which means anticipating issues or deviations in AI performance before they escalate into critical problems. You're looking for early warning signs, not just reacting to failures, and gaining inference insights to understand why the AI makes certain predictions or decisions. It's not enough to know what it decided, but why.
Then we have anomaly detection, identifying unusual patterns in AI behavior that might indicate malfunction or malicious activity, like an AI suddenly making completely out-of-character predictions. Real-time monitoring provides immediate feedback on AI performance and operational status. And let's not forget, resource monitoring, tracking computational resources used, which can impact performance and reliability. An AI starving for resources might behave unpredictably or slow down, creating safety issues.
Going beyond simple monitoring, we have AI observability. This goes further, aiming to understand the internal state and behavior of the AI model itself, not just its external outputs. It includes metrics and tools for understanding complex AI model behavior, data quality, and outputs, which is crucial for identifying issues, debugging, and ensuring consistent performance. It's like having an MRI for your AI.
This explicitly includes explainability, which is the ability to understand how an AI arrived at a specific decision or prediction, making its internal logic interpretable to humans. This is fundamental for auditing and ensuring fairness. And interpretability, which is about making complex AI models understandable overall, providing a higher level view into their general functioning.
There's also feature visualization, which helps in visualizing what aspects of the input data the AI is actually focusing on when making decisions. For example, if an AI is identifying objects in an image, feature visualization can show you exactly which pixels it's paying attention to. And understanding the fluent instance, which is about understanding the behavior and predictions of individual AI instances, rather than just the overall model's average performance. Sometimes the outliers tell the most important story.
So, if we connect this to the bigger picture, how do logging, monitoring, and observability move beyond traditional IT functions when applied to AI? It's about monitoring the decision-making process of the AI itself, isn't it? Not just its uptime or network traffic.
That's the key distinction. In traditional IT, you monitor for system health, network traffic, CPU usage, or disk space. With AI, while those are still important, you're primarily monitoring the quality of the decisions, the fairness of the outputs, the absence of bias over time, and the interpretability of the model's reasoning. This requires specialized tools and expertise to look inside the AI's brain, not just at its external behavior. It's a completely different level of scrutiny and complexity because AI isn't just executing static code, it's learning, adapting, and making judgments. It requires us to monitor for intelligence, not just infrastructure.
That truly reshapes the entire landscape of system supervision. And that brings us to our final crucial section, the human touch, or human in the loop, HITL. This brings humans back into the center of AI processes, especially for critical decisions, recognizing that full AI autonomy is not always the safest or most ethical path, despite the allure of complete automation.
The core definition of human in the loop, as per the manual, is an AI supervision strategy where humans retain primary control over critical decisions that are influenced or suggested by AI. In these scenarios, AI serves as a powerful support tool, a sophisticated advisor, but not an autonomous agent. The human is firmly in charge.
This means the human user remains the final arbiter for AI model decisions. This is particularly crucial in high-stakes situations where errors could have significant consequences. Reinforcing human responsibility and ensuring that ethical considerations, common sense, and nuanced judgment are applied. It puts the ultimate burden of decision-making squarely back on human shoulders.
There are clear and important benefits to HITL. It intentionally slows down the AI workflow for design and strategy. This might seem counterintuitive to the pervasive drive for automation and speed in technology, but it's a deliberate choice that prioritizes safety, ethical considerations, and quality over pure velocity. Sometimes, slower is safer and smarter.
Absolutely. It also allows for necessary human intervention, judgment, and the application of common sense or contextual understanding that AI may lack, especially when AI outputs are uncertain, ambiguous, or have high impact. AI excels at pattern recognition, but humans bring nuance, empathy, and an understanding of unforeseen consequences.
And critically, HITL provides a vital mechanism to correct AI errors or biases discovered during deployment, allowing for real-time adjustments and improvements that might otherwise be missed by automated systems. If an AI starts to drift or exhibit unintended behavior, a human in the loop can catch it, correct it, and help retrain the system.
The manual provides excellent practical examples that really cement this concept. Imagine a doctor making the final diagnosis for a patient. Even if an AI model provides strong recommendations based on vast amounts of patient data, medical literature, and diagnostic images. The AI informs, providing incredible insights, but the human decides, applying their experience, empathy, and understanding of the individual patient.
Or a human reviewing and approving content flagged by AI for moderation, ensuring nuanced understanding of context, sarcasm, or cultural subtleties, and avoiding false positives. This prevents unfair censorship or the removal of legitimate content if left solely to the AI. These examples clearly illustrate how AI serves as a support tool, providing data-driven insights and recommendations, but human judgment remains paramount for critical, irreversible, or highly sensitive decisions.
This raises an important question, particularly for the future of technology. HITL represents a paradigm shift from pursuing fully autonomous AI to developing AI as an intelligent assistant or guide. It acknowledges AI's strengths in processing vast data and identifying complex patterns, but also recognizes its inherent limitations, emphasizing that human critical thinking, ethics, and values are still essential, especially in a world of information overload. So what does this all mean for the future of human-AI collaboration?
It suggests a profound and necessary evolution towards a symbiotic intelligence. Instead of AI replacing humans, HITL promotes a future where humans and machines work together, leveraging each other's strengths. AI can handle the massive data crunching and pattern recognition, while humans provide the nuanced judgment, the ethical oversight, the common sense, and the accountability that AI currently lacks. It's about designing systems where the human remains the ultimate decision maker, ensuring that technology serves humanity's best interests, not the other way around. It's a powerful vision of augmented human capability.
It absolutely does. HITL isn't about distrusting AI entirely, but about intelligently designing systems that recognize AI's inherent limitations and ensure human values are integrated into its most critical applications. It's about achieving a responsible balance between automation and human oversight, ensuring that AI enhances human capabilities without diminishing human accountability or placing humans at undue risk. It's about building a future where AI is a powerful partner, not an unchecked master, and where the human element remains paramount in all critical decisions.
And that brings us to the close of this deep dive. We've navigated the complex but incredibly important landscape of AI privacy, ethical considerations, building trust, ensuring safety, and the vital role of human-in-the-loop systems. We've seen how AI's impact extends far beyond mere technical functionality, fundamentally touching individuals, organizations, and global ecosystems in profound and interconnected ways.
Our deep dive into Chapter 3, Part D of the AAISM Review Manual, first2d.pdf, has truly highlighted the critical need for comprehensive governance frameworks that address these multifaceted challenges. It's a stark reminder that the promises and power of AI can only be fully realized when underpinned by robust ethical, legal, and safety guardrails. Without these foundational elements, the risks can quickly outweigh the benefits.
This deep dive truly shows that governing AI is about much more than just cybersecurity or technical efficiency. It's about creating systems that are not only intelligent and powerful, but also inherently responsible, fair, transparent, and safe. It's a testament to the fact that cutting-edge technology demands equally advanced ethical, legal, and operational governance frameworks.
As AI continues to evolve and become even more intertwined with our daily lives, and as we push the boundaries of its capabilities, where should the line ultimately be drawn between AI autonomy and human oversight to best serve humanity's long-term interests?
And how can each of us, as learners and citizens, actively contribute to shaping a future where AI is not just advanced, but truly trustworthy and beneficial to all? Think about it. What stands out to you from today's deep dive?